Welcome everyone. So today our topic is isomorphism of graphs, and this is a portion of the graph theory, and today we will discuss that when we say that two graphs are isomorphic, and what is the actually isomorphism defined in between the graphs. So suppose G1 and G2 two graphs are given, then when we say that these two graphs are isomorphic, so this is the definition. So suppose given the graphs G1, and suppose G1 is a graph with the vertex set V1 and the edge set E1, and G2 is equal to vertex set V2 and the edge set E2, then G1 is isomorphic to G2. G1 is isomorphic to G2 if, that means it is denoted by G1 is isomorphic to G2, and if there exists a 1 1 function on 1 and obviously onto function, 1 onto function, that means a bijective function onto function phi, and from this V1 set, that means vertex set V1 to the vertex set V2, and such that this condition holds. Number one, if suppose V comma W is an edge of the graph G1, then this f of V, not f, our function is phi, so then this phi of V and comma phi of W is also an edge of G2. This is the first condition. That means if V and W actually produce an edge in the graph G1, then their image phi of V and phi of W also produce an edge in the graph G2. And number two, for every edges or every edge in E2 has the form, that means the edge set of G2. So every edge in E2, that means every edges of the graph G2 and has the form phi of V and comma phi of W, every edge, and for some edge and VW and belongs to, we said that as V comma W and belongs to the edge set E1. So this is the onto condition. That means if you take any one edge from the graph G2, then you will get one correspondence also in the graph E1, and it is holds for every pair of vertices. So then we call this phi, and isomorphism from G1 to G2. That means phi is an isomorphism from G1 to G2. So this is the condition. So that means you will always get an correspondence 1 1 on 2. That means a bijection correspondence and between the graph G1 and the graph G2. So If you see one example, that means one more thing. So if G1 is isomorphic to G2, if G1 is isomorphic to G2, then obviously G2 is also isomorphic to G1. G2 is also isomorphic to G1. G1. Now just take this graph. So suppose this is one graph, and suppose H, and take this as another graph. Here this is the H. Suppose these two are graph, and where the vertices are suppose V1, V2, suppose this is V3, this is V4 and V5, and if we denote the corresponding edges as, suppose there are two 3-degree vertices V1 and V3, so and there is one, so if we give it V1, suppose this is U1, this as suppose U3, and if we give it as U2 and this as U4 and it as U5, if we give it in this way, so and then the V1 V2 connection, this is suppose U1 and this is suppose U1 prime, V2 V3 it is suppose E2, it is E2 prime, and suppose V3 V4 this is E3 and this is E3 prime, and U1 U4 it is E4, it is E4 prime, and it is E5 and it is suppose E5 prime. So now if you see that these two graphs, so there is a correspondence between them. So this actually looks different, just the presentation is different, but if you see the degree of the V1 vertex is here 1, 2, 3, and here the U1 vertex is also 3. Degree of the V3 is here 3 and degree of the U3 is here 3. Degree of V4 is here 3 and degree of the U4 is here 3. And this is a pendant vertex V5, here the pendant vertex is U5, and here the V2 is the degree 2 vertex and here U2 is the degree 2 vertex. So we actually take this type of association. So if we now uh, produce a function phi or mapping in this way, so phi is the mapping from the V1 to the vertex set, suppose from the V to the U, from the V to the U. So where this V is the vertex set V1, V2, V3, V4 and V5, and where U is the vertex set of the second set, that means if this is G1 and if this graph is G2, then U1, U2, U3, U4 and U5, and if we define the function in this way, that phi of Vi actually goes to Ui, and where I is equal to 1, 2, 3, 4 and 5, and the phi function of the edges, this Ei actually goes to Ei, Ej goes to Ej prime, where j value is 1, 2, 3, 4 and 5. So then you can see that there is one 1 and on 2 correspondence between these two graphs. That means corresponding to every Ei, Ej prime, you will get one Ei here, Ej here, and similarly for corresponding to every vertex here, you will get another vertex in the set G2. So that means we can say that this phi is an isomorphism from G1 or from V1 to from V to U, from V to U, and this G1 and G2 are isomorphic, and this G1 and G2 are isomorphic. So this is the way of checking the isomorphism. So now whenever there is some problem, you have to remember that how to check this isomorphism, how to write down the problems, actually the solution of the problems. So some key observations or checking in this isomorphism topic. The thing is, if the graph, suppose G1 and G2 are isomorphic, or G and H, we actually use this rapidly. If G and H are isomorphic, then number one, the number of vertices, of both graph will be same. Both graph will be same. Number two, the number of edges, of both graph will be same, will be also same. And number three, degree of the corresponding vertex, degrees of the corresponding vertices will be same also, will be same. So these are the three properties. If G and H graphs are isomorphic, then these three obviously holds. So both have the same number of vertices and the same number of degrees, and also the corresponding vertices have the same degrees. So that means if any of this condition fails in your given graphs, so then you can say that your graphs are not isomorphic. So first check that, is there same number of vertices, is there same number of edges, is there, if the degree of the corresponding vertices are same, and after that we can check the correspondence, or we can define the function to make it isomorphic. So now check whether these two functions are isomorphic or not. So number one, so check whether, this is the problem, check whether the following two graphs are isomorphic, Okay, just check it. So the graphs are, suppose this is one graph, and these bold points are the vertex, and then another graph, this is the graph, okay, this is 1, 2 and 3, and now suppose this is the graph. Okay, so check whether the following graphs are isomorphic or not. So in this graph, so first what you have to check, so number one, check that if you take it as an algorithm, so number one, is the number of vertices same in both graphs? So here you can see that number of vertices present in the set V. So if you take this as the G set, and if you take this as H set, so number of vertices of G, number of vertices of G is equal to 1, 2, 3 and 4, but the number of vertices of the graph H, this is equal to 3. So these are different. So G and H are not isomorphic. Okay. This is the first thing. So this is the first checking what you have to do. So is the number of vertices are same. So now again take the similar problem, number 2, again take the similar problem. Now your graphs are that graphs. So here this graph have 1, 2, 3 and 4 vertex, and here also you have 1, 2, 3, and suppose there are 4 vertex where these are connected by this type of relations. So this is another graph. So this is G. Now this is your G and this is your H. Now check it. So check the isomorphism. Check the isomorphism. So check for the isomorphism. So here also check the same thing. Now you can see the second checking is, so first checking is the number of vertices in the both graph are same, so it will pass. There is 4 number of vertices, so here also the 4 number of vertices are there. So now the second checking is the number of edges are same in both graphs. In both graphs. Okay. Is the number of edges are same in both graphs. Here you can see 1, 2, 3, 4 and 5. Here also 1, 2, 3, 4, 5 and there is 6. So here in this graph number of edges are 6, but here in this graph number of edges are 5. So number of edges in G1 or G is 5, whereas the number of edges in the graph H is 6. So that's why they are not isomorphic. They are not isomorphic. Then suppose if we take here number 3, another problem with the same type of graphs. So here the graph is, the first graph is that one here and another is here. So that means that the graph is V1 and okay, it was not actually giving the vertices. This graph is G and there are 4 number of vertices and 5 number of edges. And similarly draw here another graph and with the 4 number of vertices, the same number 1, 2, 3 and here suppose 4 number of vertices, and we are connecting this graph in this way that there are 1, 2, 3, 4 and 5. Okay. So this is the graph and where just minutes we can, there are total number of vertices is 4. Okay. So if we draw this by a line, now you can see that there are total number of vertices. This is equal to 1, 2, 3 and 4. So here also 1, 2, 3 and 4. Okay. And so number of vertices are same. So here in the checking, so this is H. So number of vertices are same. Number of vertices are same. And number 2, the number of edges 1, 2, 3, 4 and 5. Here also 1, 2, 3, 4 and 5. So the number of edges is also same. Number of edges are also same. After that, we will find the degree of each vertices. So here degree is 3, here the degree is 3, here the degree is 2 and here the degree is 2. So here also degree is 2 and degree is 3, here degree is 3. So number of degrees of the corresponding vertices are also same. So number 3, degrees of the corresponding vertices are same. Corresponding vertices are same. So what happens if we draw this type of graph, not with that? Suppose if we omit one edges from here and if we add another edges here, so if this is your graph, so in that case you can see the total number of vertices is 1, 2, 3 and 4. That means number of vertices are 4 in both cases, and number of edges are 1, 2, 3, 4 and 5. Number of edges are also 5 in both edges. But here this vertex have a degree 3, this vertex have a degree 2 and this vertex have a degree 2 and here degree 2 and this vertex have a degree 1. Okay. So this is the now figure and you can see that the degrees of the corresponding vertices structure are now different for these two graphs. So if we take this as a problem, after that actually we comes to the isomorphism topic. So first this figure fails into the number of vertices, this figure fails into the number of edges, and here both number of vertices and number of edges are same, but here it fails to the degree of the corresponding vertices. So degree of the corresponding vertices are not same in this figure. So here again we can say that G and H are not isomorphic. H are not isomorphic. Okay. So in which environment we can set it to be an isomorphic map? So this is important. So just take these two curves, what we just have taken. So here number 4. So this is the graph, and just 1 minute. The graph, and here these are the 4 number of vertex, and here this is another graph where we have taken this type of figure, drawn these two, and here we already verified that number of edges and number of vertices and the corresponding degrees are also same in the vertices. So number 3 and number 3, and this is number 2 and number 2. So we can associate. So first we are writing the observation. So number 1. So number of vertices are same. Vertices are same in both graphs. In both graphs. Then number 2. Number of edges are same in both graph. In both graph. And number 3. Degrees of the corresponding vertices. So degrees of the corresponding vertices or the degree structures, we can say that we next we go to the corresponding. So degree structures of the vertices are same. Of the vertices are same. So after passing all these three checks, now what we have to do, the next our job is to mark the vertex of. So this is the next step. So mark the vertex of or the vertices, marks the vertices of the first graph G arbitrarily. What you may have chosen, you can give anything. So mark it as V1, this as V2, this as V3, and this as V4, and also the edges of this. So mark it as E1 and mark it as E2, it as E3, it is E4, and it is E5. Okay, so we have marked the E1, E2, E3, E4, E5, all this, and after that you have to mark the corresponding vertices and by just observing the degrees. That means here this V1 has a degree 3 and here this V3 have a degree 3, and so mark the vertices and then mark the degrees of G arbitrarily. Okay. Now you have to mark the then mark the edge graph by preserving the edge relation, or the bijection. So that's why this isomorphism is also called an edge preserving bisection. Though this bisection is also called the edge preserving bijection, because we preserve the edges here. So now just see that these are 2 degree 3 vertices and these two are 2 degree vertices. So you can connect only 3 degree vertices to 1 3 degree vertices, not to 1 2 degree vertices or any other degree vertices. So that's why you can choose this as V1 and this as V3. Choose this as V1 and this as V3. Okay, so you can also choose this as V3 and this as V1. This is also another. So we can say that bijective map 1, and we can set another bijective map 2. So just for understanding, we are doing multiple bijection map. We need only one map. So there may be more than one map also. So that means in the first map, we are preserving this relation in this way. So the V1 image, here we are taking here, it is U1 and it is suppose U3. Okay. So first relation is we are taking that V1 goes to U1 and this V3 goes to U3. Okay. And the edges between this V1 and V3, it is the same edges between that. So this is E3 prime, and we are saying that the E3 edge goes to E3 prime. After that, the U2 can be chosen as this. So we are taking this as U2 and this as U4. So that means V2 goes to U2 and V4 goes to U4. So this is the vertex mapping, and corresponding edge mapping are now V1 V2 here connect the U1 and U2, so it is U1 prime. So we can say that U1 goes to U1 prime. Now here V1 and V4 here U1 and U4, so it is E2, that means it is E2 prime. So E2 goes to E2 prime. Now it is V2 V3 and here it is U2 U3, so it is E4 prime. So that means E4 goes to E4 prime, and similarly E5 goes to E5 prime. So E5 goes to E5 prime. So this is one bijective map from this. So phi is defined as, so if we the bijective map phi 1, or we are taking phi defined as that, defined as this. Also you can define the bijective map. This is the alternative bijective map, alternative, just another. You can define it also in this way, that V1, so let it take what, that is map this V1 to this U3 and we will map this V3 to that U1. Okay. So now the V1 goes to U3. So V1 goes to U3 and this V3 goes to U1. V3 goes to U1. So in between these two, so that means our new map, we have to defining this map. So we are just changing these variables. So this is now, so V1 now goes to here, V3. So this is U1. And next what? Next you can see that V2, also you can change this V2 and V4 relation. So also you can take this as same. So we are taking that V2 goes to U4 now. So V2 goes to U and U4 and this V4 goes to U2. Now see. So this is your new graph. That means in the new graph, so your figure is like this. So just take the figure here. So it is the figure. So here we are taken. So V1 goes to U3 and it is U1. V2 goes to U2 and this is U of 4. Now, if you take this as E2 prime again, now E2 prime, here the relation between them is, suppose V1 V2, there is what? There is U1. Okay. And V1 goes to where? V1 goes to U3 and V3 goes to U1. So that means here now just understood the relation between them. So if there is an edge between these two vertex V1 and V2, that is E1, this is E1, then there will be an edges, corresponding edges between this U3 and U4, and in this U3 U4 your edge will be suppose U1 prime. We are taking that. So here in between this U3 and U4 you will get the what, U1 prime edge. Okay, so this is your figure in that case, and with respect to this you will get this same edge relation here. So corresponding to that V1 to U3 and corresponding to V2 to U4, here the edge mapping is that U1 goes to U1 prime. We are taking the same relation here, so it is U1 prime. Similarly, now take the second relation. So this edge is already over. Now take this edge corresponding to V1 and V3. So corresponding to V1 and V3. So if you take these two, V1 and V3, so you have to take the edge between U1 and U3. So V1 to V3 there is an edge E3. So here also in between U1 and U3. So U1 and U3 here you have an edge E3 prime. So that means that it will be same. U1 goes to U1 prime and U1 next. So first the U1 goes to U1 prime and here E3 goes to E3 prime, E3 prime. And similarly, the third edge, it is between V1 and V4. So it is between V1 and V4. So what is the edge between V1 and V4? This is E2. And here you will give the notation in U2 and U3. So here in the U2 and U3, you will give this. Where is U2, U3? Here, this is U2, U3. So this will be your E2 prime. Same thing, E2 prime. So E2 again goes to E2 prime. Now in the next stage, here in between V2 and V3, so here you will take the V2, V3, that means U1 and U4. So in between the U1 and U4, you will get the E4 prime, and similarly, so E4 goes to E4 prime, and here this E5 goes to E5 prime, E5 goes to E5 prime. So you can see that edge relation are same, but we have changed the vertex relation here, not like the previous way. So that's why this is called an edge preserving relation. So we have taken the edges as the same structure, but we have changed the vertices. So in this way you can change the vertices to produce another bijection mapping also. But we will always prefer this first bijective relation, because you can represent this bijective relation as, so if phi is your bijectiveness, so phi of simply Vi goes to Ui, and where I is equal to 1, 2, 3 and 4, and under this phi the E relation Ej will goes to the Ej prime, and where this Ej prime or J is equal to 1, 2, 3, 4 and 5. So under this bijective map we can say that this G1 and G2, this G and H, these two graphs are isomorphic. This G and H graphs are isomorphic. So here G and H are isomorphic. You can say that. But we said this bijective mapping in this way, but before writing this, that G and H are isomorphic, to verify that our bijective mapping is okay or correct, so we have to check the incident matrix for both of these matrices. So just check the incident matrix. After that we can say that these two graphs are isomorphic. So this is the next. So check the incidence matrix after just assigning all these vertices and the edges. So check the incidence matrix of both graphs. If they are same, then we say that G and H are isomorphic. Okay. So that's the next process. So from where we start, so first check the number of vertices, then check the number of edges, then check the degree structure of both graphs if they are alike. Then we go to the next step, which is defining the bijective map. So we define one bijective map in this way that incident matrices will be same. So after defining the mapping, then calculate the incident matrix for both the graph G and H. And if these two graphs matrices are same, then we can say that G and H are isomorphic. So just calculate the matrix, incident matrix of these two variables. So just now we are calculating the incident matrix for the first. So this is suppose incident matrix M of G. We are denoting that as M of G. So what is the MG? Here the incident matrix is, just take here view E1, E2, E3, E4 and what E5, 5, and after that these are V1, V2, V3 and V4. Okay, so now just check the relationship of this edge and the vertex. Just check the relation, minutes, just okay. So here E1 is connected to V1 and V2. So in V1 and V2 put 1 1 and other value 0. E2 is connected with V1 and V4. So in V1 and V4 put 1 and other 0. E3 is connected with V1 and V3. So V1 and V3 and put the other 0. E4 is connected with V2 and V3. So put V2 and V3 plus 1 other 0. And E5 is connected with V3 and V4. So put here 1 and 1 and the other value 0. So this is the incident matrix for the MG. So this is the incident matrix. And after that, calculate the same incident matrix for the, so this is the incident matrix for the M of H. So M of H, the incident matrix, and this incident matrix is equal to, again, the same thing you have to do. So just write here E1 prime, E2 prime, E3 prime, E4 prime and E5 prime. So these are prime, and here it are U1, U2, U3, U4 and U5. Now just check it. So U1 prime is actually related to U1 and U2. So put 1 and 1 here and all the other values 0. Then E2 prime is related to U1 and U4. So put 1 and 1 here and the other values as 0. So E3 prime will be U1 and U3, U1 and U3 and the other value is 0. E4 prime will be U2 and U3. So put here U2 and U3 1 1 and all the other values are, okay, why we are taking the U5 here? These are U4, no? 1 1 U4. No, there will be no. So this is not 1 1 0 0. This is connected with U1 and U4. Okay, E2 prime. E2 prime connected with U1 and U4. And then E3 prime connected with U2 and U3. E3 prime, U2 and U3. E3 prime. U1 and U3, it is okay. Then E4 prime connected with U2 and U3. And then E5 prime is connected with U3 and U4. U3 and U4, and these two values are 0. Okay. Now, if you see these two matrices, then you can easily verify that actually these two matrices are. So this is the incident matrix of G, incidence matrix of G, and this is the incidence matrix of H, and they are same. They are same. Actually, we define the mapping in this way that they will be same, but this is just for the verification. So since they are same, so we can say that G and H are isomorphic to each other, are isomorphic under this mapping. Okay, under this isomorphism, under the isomorphism phi, under the isomorphism phi. So phi is that mapping. So mapping is called the isomorphism, and these are G and H are called to be isomorphic. Okay. So this is one of the problem from the isomorphism of the graph. So now You can take another problem just to clarify it better. So, and this is our last problem from the isomorphism of the graph. So just take it, the check the isomorphism, check the isomorphism of the graphs of the graphs of the graphs G1 and G2, G1 and G2 given as follows, given as follows. So this is the first graphs, first graphs 1, 2, 3 and 4, and this is the second graph. Mhm. And this graph is G1 and this graph is G2. Okay. Now you have to check the isomorphism of these two graphs. So number one, if you start, you can see that there are total 8 number of vertices in both. So number of vertices are 8, vertices is 8 or are 8 in both graphs, in both graphs. Number 2, the number of edges, there are 4, 4, 8 and 4, 12, here also 12. So number of edges are 12 in both graphs, in both graphs. Number 3, if you see the degree structure of these two graphs, then you can see that this graph have a degree 3, here degree 3. So just we are writing it here, here 3, here also 3, here also 3, here also 3, and these are 3, 3, 3 and 3 and all. So you can see that all the vertices are of degree 3. So here also these are 3, 3, this is also 3 and this is also 3, and here this is also 3, 3, 3 and 3. So the degree structure of both the graphs are also same. So the degree structure are also same for both graphs, for both graphs. So that means each graph have 8 number of vertices with 3 degree each. Now we define the phi in this way. So that's why first we have to arbitrarily defining the vertices of this graph G1. So just try. So take this as V1, this as V2, this as V3, this as V4, and take it as V5, it is V6, and it as V7, it as V8. And corresponding edges are, suppose this is E1, this is E2, this is E3, this is E4, this is suppose E5, this is E6, E7, this is E8, E9, it is E10, it is E11 and it is E12. So these are the corresponding vertices. So it will be better if the graph is size and big in size. So that's the vertices. This is E9, E10, E11 and E12. Now we have to preserve this relation here. So that's why we are just writing this in a large form so that it will be easier to mark the vertices. So just take it like this. So here the vertices are that. Okay. So after that, now we will mark each of the vertices here. So first of all, V1, V2, V3, V4, these are the outer side. So just take here also in the same way. So this is this as U1, take it as U1 and U2. take it as u3 and take it as u4 in the clockwise rotation. And here also this u1 is actually connected to what? V8 here, and so that's why take it as u8, it would be better. So u1 connected with u8, u4 connected with what? u5, here v5. So u4 connected with u5 and u3 connected with u6, and here u2 connected with u7. So 5, 6, 7 and 8. So that's the vertex relation. So phi is defined. So here capital V vertex set is equal to V1, V2, V3, V4, V5, V6, V7 and V8, these are. And capital U is equal to U1, U2, U3, U4, U5, U6 and U7 and U8. These are the, and now the phi is defined in this way from V to U, such that under this phi the Vi is mapped to the Ui, and where I is equal to 1 to up to 8. And now we set the edge preserving relation as phi of Ei, phi of Ej, this as Ej prime, and where j is equal to starting from 1 to and up to 12. So now we will mark the edges as per this mapping. So here you can see that the first, so just start with the above portion. So in V1 and V2 there is U1, so it will be U1 prime. U2 and U3 it will be E2 prime, and U3 and U4 it will be E3 prime, and U4 and U1 it will be E4 prime. Okay. After that, over here starting from the again here V5. So starting from the V5 and V6, V5 and V6 it is E11. So take it as E11 prime, and here V6 V7 it is E10. So take it as E10 prime. V7 V8 it is E9. So take it as E9 prime, and V5 and V8 it is E12. So take it as E12 prime. After that we take these joining edges. So V1 and here V8 connect with E8, so it is E8 prime. Here U2 and U7, that means here V2 and V7 connect with E7, so take this as E7 prime. Here U3 U6, that means V3 V6, it is E6, so take it as E6 prime. And here U4 and U5, this is E5, that means it is E5 prime. Okay. So that's the edge relation of the second matrix, second graphs. So now corresponding to this graph, now we will check that this incident matrices are same or not. So now the incidence matrix of graph G1. So this is the G2 graph. So graph G1 is, suppose A of G1, or not we taking at M. So M of G1, this is equal to this one graph, and where there are so many edges are there, so it will be a lengthy incident matrix. So in this graph there will be E1, E2, E3, E4, E5, E6, E7, E8, E9, E10, E11 and E12. So it will be very lengthy. So that's why we are taking one more pages to discuss it, because we will need one lengthy page here. Just I'm taking one duplicate page, and just 1 minute. So we are omitting all this writing. So now again start. So first the incident matrix of the graph G1 is, suppose M of G1. So this Mg1 is equal to what? Take one large matrix and starting with E1, E2, E3, E1, E2, E3, E4, E5, E6, E7, E8, E9, E10, E11 and E12. And here V1, V2, V3, V4, V5, V6, V7 and V8. So this will be the incident matrix, and here this U1 is connected with, you can see the, if we take first the U1, so here this U1 is connected with V1 and V2, so put 1 and 1 and every other place it is 0. E2 is connected with V2 and V3, V2 and V3 and every other place is a 0. And E3 is connected with V3 and V4, so V3 and V4 and other values are 0. And here E4 is connected with V1 and V4, V1 and V4 and other values as 0. Next, E5 is connected with V4 and V5, V4 and V5, other values 0. And E6 is connected with V3 and V6, so V3 plus 1 and V6 plus 1 and the other value 0. E7 is connected with V2 and V7, so V2 and V7 and put the other values as 0 value. And E8 is connected with V1 and V8, V1 and V8 and place the other values 0. Then E9 connect V7 and V8, E9 connect V7 and V8, E10 connect V6 and V7, V6 and V7, and then E11 connect V5 and V6, E11 connect V5 and V6, and E12 connects the V5 and V8, E12 connects the V5 and V8. This is 0. Okay. Now similarly, if you change the same matrix, that means just by replacing the U1 and the U1 prime, then you will see that just I am taking one of the snapshot of this figure and we will change it by the value. So just take it and saving it with some values, and after that we are taking the same thing here. Okay, minutes. So the incident matrix for this graph will be also same. So if you take this as the G2 matrix, and if you take this as an G2 matrix, suppose, and the values are suppose 0, so just put it here. And if you put this as an new values, suppose if you take this as G2 MG2, so this MG2 will be simply, these are not V1, V2, V3, V4, this type of value. So it will be some U1, U2, this type of values will be there, and you can see that this value will be same. Just hit here, and so this value will be U1, U2, U3, U4, U5, U6, U7 and U8, and corresponding to this value will be prime values, E3 prime, E4 prime. These are the prime values, and just verify this graph, and obviously you will get the same incident matrix for this, because we define the isomorphism or the mapping by preserving this. Okay, so by preserving the edge relation, so that's why if you manually do this, you will get the same incident matrix. So now we can say that this Mg1 is actually same as the Mg2, is equal to same as the Mg2. That means the incident matrix are same, so we can say that G1 and G2 are isomorphic. G2 are isomorphic. So that's the topic, isomorphism, and this is a very important topic for the exam. So now take one or two homework problems just so that you can do it better. So number one problem is check the isomorphism isomorphism of the following maps. So now take just one, two, or three numbers of problem. So isomorphism of the following graphs. Following graphs. So number one, check these two graphs are they isomorphic or not. Number one, this is the first graph. Okay, first graph, and then this is. So these bold marked are the vertices here. These bold marks, and here another. This is another graph, and where this is like that, and that is also like that. So here these are the vertices. These bold points are the vertex. And number two, this another problem. This is a bipartite graph. We all know that. This is a K23 graph, not a bipartite graph of K2, 3. And here also do the same thing with the other from 1 to 2 and from 1 to 2. So 1, 2, 3 and 4, 5, 6. So these are the 6 number of vertex level, and there are 1, 2, 3, 4, 5, 6 number edges. And take another problem similarly here, and just take it 1, 2, 3, 4, 5 and 6 number of edges. 1, 2, 3 and 4, 5 number of vertices, both are same. 5 vertices and 6 number. This is not one vertex, so these bolts marking are only the vertex set. And number 3, another problem, and which is that 1, 2, 3 and 4, and here also the same. Just take it in this 1, 2, 3 and 4. These are 1, 2, 3 and 4, and this is 1, 2, 3 and 4 vertices. Okay, so these are problems and for the homework, so just try it. Okay, and that's the end of today's lecture. So thank you all for watching.